Hi, this is a video on formula weights in chemistry, and although any chemistry course is going to cover it, I'm kind of following the train of thought of Chemistry, the Central Science by Brown, LeMay, Burston, and Murphy. So formula weights. What are formula weights? Well, basically the formula weight, FW, of a substance is the sum of the atomic weights of each atom in the chemical formula of that substance. So take water, for example. We have two hydrogens and one oxygen. Well, the atomic weight of hydrogen is 1. So we have two hydrogens. So that gives us 2 times 1 atomic mass unit. And then we have one oxygen, which is 16 atomic mass units. So I'm going to add that all up. I'm going to have the 2 hydrogen atomic mass units plus 16 oxygen atomic mass units. So basically the formula weight of water is 18 atomic mass units. Again, this seems pretty simple, really. So what about formula weight versus molecular weight? As it turns out, there really isn't that big of a deal between formula weight and molecular weight. It just depends on whether you're talking about a molecule or not. And here, chemists don't really call ionic substances like sodium chloride molecules. That is, molecules whose bonding is ionic by charge. They are more in arrays rather than self-contained little nuclear units, family units, 2.5 kids. Ionic substances like salt usually aren't called molecules. We speak of rather formula units because they're in these big arrays of electrically attracted bits. So this is a matter of definition, really. So the phrase molecular weight is usually reserved for molecules which might have covalent bonding instead of ionic bonding. But it's really when it comes to molecules, the molecular weight is the same as the formula weight of a molecule. It's just that they don't call ionic bonded units molecules. Again, not important, really. It's just what you call something. The principle is the same. You're going to add up the atomic weights of each of the parts, each of the subatoms, and the number by the number of atoms, and that's going to give you the formula weight or molecular weight. Okay? Now, this section also talks about percentage composition. Let's say you wanted to figure out what percentage of sulfuric acid was hydrogen or something like that. Basically, the percentage of element in a compound is the number of atoms of that element times the atomic weight of that element divided by the formula weight of the compound. Again, this is fairly straightforward. So we've figured out how to find the formula weight of a compound. We just add up basically the atomic weights and multiply them by the number of atoms of that kind there are. So we know how to find the formula weight. The atomic weight of an element is, again, we look it up in the periodic chart. And so let's look at calcium nitrate here. So what is the percentage of oxygen in this compound? Well, so we have 6 atoms of oxygen in this compound. 3 times 2 is 6. 6 atoms of oxygen. The atomic mass unit, number of atomic mass units in an oxygen is 16. So we multiply those two together, and therefore we know the total number of atomic mass units of oxygen in any one molecule of the calcium nitrate. So in one of the exercises in this section, they added up to find the formula weight of the whole thing. Calcium plus 2 nitrogens plus 6 oxygens, and it adds up to 164.1 atomic mass units. So if we divide 6 times 16, the number of total oxygen atomic mass units in this thing, and divide it by the total of atomic mass units of all of the atoms, we end up with 0.585, which if you multiply by 100 is 58.5%. So basically the percentage composition of oxygen in calcium nitrate is 58.5%. So there, we've learned about formula weights and we've learned about percentage composition in this short section.